Okay, for 1.3, problem number 36, there's a little trick that we could use to determine if something is exponential. And so we're going to actually start with the exponential function. In the real world, what we do is we look at data and we try to see, hey, is this exponential? Is it a polynomial? Is it linear? But I want to show you a characteristic of exponential functions. So if I look at some x values and some y values and then the ratio between the y's. In other words, if I let x equal 1, 2, 3, and 4, what I want to do to find the y value, I'm just going to plug that in. So for example, if I said y is equal to 3e to the 1, okay, that's going to be approximately, remember the e is equal to 2, it's the same as saying 3 times 2.71. So when I plug that in that way for my y value, I would get 8.155. And so then if I let x equal 2, 3e to the 2, that would give me 22.167. So I would get 22.167. If I were to do that again and let x equal 3e raised to the 3, that would give me 60.257. So when x equals, when x equals 3, y equals 60.257. And if I were to do that again with 4, I would get 163.749. Now what we want to do is we want to look at the ratio. We're going to compare the y's. So if I take this number, and in other words, if I say 22.167 and put it over the previous y value, which is 8.155, I will get approximately, and you're going to love this, 2.718. If I were to do that again with 60.257 all over the previous y value, which is 22.167, approximately, guess what that is? 2.718. Sometimes, you know what, I should carry that out, it's 2.72. But anyways, what you'll see is if we continue down that path, in other words, if I say 163.794, divide that by 60.257, you guessed it, 2.718, which is E. So the ratio here is always going to be the base in these exponential functions. That's basically what problem number 36 is trying to teach us. Any questions?